Hello guys, welcome to the camera channel. I am Mansour Amini. In this session we are going to simulate alkylation unit. In the previous video we have talked about pumps and how to calculate NPSH calculation or net positive suction head in a pump, in the suction side of a pump, and using HYSYS and a spreadsheet and actually calculate NPSH by yourself. So in this session we are going to simulate alkylation unit. So let me explain what is alkylation unit first and then go to the simulation area in the HYSYS software. So in the HYSYS, actually in the alkylation unit, our purpose is that you turn the low weight component into the higher or more density component, in which in this case we are going to turn actually isobutane into the alkylate. That alkylate is more heavier than isobutane, and so how we can turn this isobutane to the heavier components. So let me explain this. We have a feed which enrich in isobutane and send it into the alkylation unit, and with the alkylation unit we have H2SO4 in this case as our a component which is responsible for turning our feed into the higher product, more dense and more molecular weight components. We insert H2SO4 into the calculation unit, and then in the refinery we separate them by a shortcut column, and we have a product right here, alkylate, and then we send back our other component C1, C2, C3, C4 and lighter component with the recycle to the feed and mix them and then send them to the alkylation unit. So let's simulate alkylation unit. I have inserted ALKY feed just right here because it has a lot of component. If you are going to simulate alkylation unit, you have to insert all these components into the simulation areas and go to the simulation. So let me first explain how to insert 53 hypothetical component into the simulation area, and I assume that you have learned and you know how to insert this full group into the simulation area. So let's jump and learn how to insert this component into the simulation. We have 53 component which initial boiling temperature, boiling point is 41 degree C and its final is 865. So I have inserted this component into the simulation just right here. These are all hypothetical components which I have inserted into the simulation area, but I'm going to learn you how to insert this composition into the simulation. Click on Add, just switch on the hypothetical and go to the number of hypo and insert 53 as the number of hypo which we are going to insert. Initial boiling point is 41 degrees C and final boiling point is 865 degrees C. So we have insert all the data just right here, and just you know that all these information are given by the lab to us to simulate, and so click on generate hypos. We have inserted all the hypo into the simulation area from 41 integrity, and its final is 865. So HYSYS software actually automatically, calculate all the properties right here for you. And then after inserting all the data, just click add all, and then all the component come here, and then you can insert these four group as well into the simulation area. So I assume you can insert all these components. So let me delete these two, and for the fluid packages, just choose Peng Robinson as the fluid packages. So let's go to the simulation. We have a ALKY feed with which its criteria are given right here. Its temperature is 30 degrees C, pressure is 172 kPa, and flow rate is 66. I have inserted all these properties right here, 30, and this is all the data which I have inserted. And for the composition, all the ALKY feed composition are given in the table for you. Just insert all these properties into the simulation area, and then equal sorry and then all the other component mole fraction is equal to 0, which I have not mentioned in the table. So insert this component as well. Just stop the video and insert this component by yourself, because we do not have enough time to just insert all these components. For the fresh ibutane stream, we have temperature, pressure as the same as above, and cubic flow is 72 meter, actually cubic meter per hour. So let me insert, and if you do not have model and templates, go to the flowsheet and modify, click on model and streams. This is the fresh ibutane stream. Fresh ibutane. Temperature is the same as the ALKY feed. Pressure is 172 kP. So it's not the pressure. Pressure is 172 kPa, and flow is 72. After inserting this, go to the composition and ibutane and insert one, because ibutane is the only component which we have in the fresh ibutane. So then insert the mixer I'm going to send this to the mixer, and then we have outlet for a mixed isobutane. So we have defined properties right here. We have to insert a recycle right here, but just let me skip this step, and at the end of the video I will insert the recycle into the mixer. So alky feed and mixed isobutane, then mix to each other by another mixer as well, and we have one outlet as the feed. After inserting these two, we have alkylation feed and fresh isobutane. Then we have two kinds of alkylation unit. The first one a hydrofluoric alkylation unit, and the second one is H2SO4, which I'm going to teach you how to simulate H2SO4 in this session. So let me stop the video after inserting this. No, it's okay. Just insert this, and we have one outlet as well. This is the alkylation outlet, and in the alkylation reactor we have to insert volume and outlet temperature for the reactor, that its information are given below. Right here. So volume is 60 and outlet temperature is 15 degrees C. Just insert this number, 60 as the volume, and outlet temperature is 15 degrees C. H2SO4 acid fluoride is 650 and acid concentration is 98. Insert this number too. This is 98, 650. So after inserting this number, alkylation unit will run correctly. Then we, as I mentioned in this picture, we have simulated alkylation unit with H2SO4, and then we are going to insert into the refinery, and we have two products and separate them to each other by a column. Go to separator and insert refinery short column. The difference between refinery short column and distillation column is that in the refinery short column we can insert just one inlet. This is the main difference between this and distillation column. And the second one is that the refinery short column just calculate a simple and not complex mass and heat balance for us. So we use this for when we do not have any detailed information for our distillation column. So after inserting the shortcut column distillation, we have two ways to run the simulation. Specification type is ECP or yield. You have the yield fraction for the ECP as the temperature. So in this case, we have the ECP as the temperature. So empty steam pressure, just make sure that you insert all this data as 101.3 kPa. So insert this for all the stream right here. After inserting a stream, the software asks you to insert the ECP as well, or when you click on the yield, the software asks you to insert the yield fraction. So in this case, I'm going to insert ECP. So in the refinery information, we have minus 30 for the ibutane out, and for the C4 out is minus 5, and alkylate is 10. Alkylate is the bottom of our column. I'm going to insert 10 for the bottom, and C4 is one level above the alkylate, and the ibutane is another one. So let me insert this stream, this ECP minus 30, minus 5, and 10. Minus 30, minus 5, and 10. After inserting all this data, you have correctly simulate this. So what is this? This is a water draw. So let me change the name for the better understanding. This is the C1 out, or the light component, I mean. It's an alkylate. This is our product, alkylate. Alkylate. The heavier product which we need, and this two one is ibutane out and C4 out. Set ibutane out, set C4 outlet. So after running the shortcut column refinery, we need to recycle ibutane into the mixer, which I have mentioned. So we need a recycle, go to all and insert, just bring recycle into the simulation area, and so let me delete this one. We need to connect this to the recycle, and then this. So let me save this simulation. Into the desktop. So after inserting this recycle, just make sure you have saved your data, because sometimes recycle would not work well and you need to save it first. Just make sure that you have the simulation for yourself. So after that, insert this recycle as the ibutane, that exit. This is the outlet stream of iButane from the refinery which come to the mixer for running the simulation. Just press Ctrl and drag this stream and insert it to the mixer. So all the simulation have correctly run, which we turn the ALKY feed with the light component into the more denser and more heavier component, which is really suitable for the engine in the vehicle that actually help us to have a better combustion in the vehicle engine. So if you found this video helpful, just subscribe and follow my channel. And if you have any question or any critique, just let me leave a comment, and or I will give you my email as well to just say what you want to say. Thank you guys. Have a good time. Goodbye.